What's up, guys? This is Michael with Michael Talks Metal, back for another session on some metal. So let's jump in. Appreciate you guys watching. Today, we are going to talk about a category of alloy steels that achieve very high strength levels with a simple heat treatment after the manufacture of the part. These alloys are called Maraging steels. Mar for martensite, aging, and how they develop their strength. And that makes Maraging. Conventional steel alloys like 4340 that can achieve comparable strength levels have a minimum carbon content of 0.40% and require a high temperature austenitizing step followed by a rapid quenching and then a final tempering to develop their strength. Needless to say, this process can be very troublesome, and it can also provide a significant amount of difficulty in many different part configurations. With these carbon levels, any welding requirement can be very problematic. Maraging steels simplify the heat treatment since they require only a single-step, low-temperature heat treatment with no drastic quench. This Maraging category of steel has low carbon content which lends greater toughness at high strength levels as compared to the higher carbon alloy steels at similar strength levels. Weldability is also much improved owing to the lower carbon. They are highly alloyed steels where the major elements are nickel, cobalt, and molybdenum, which allow the formation of a stable martensitic structure in the annealed condition, and the minor elements, titanium and aluminum, can strengthen the microstructure when it receives the aging heat treatment after parts are manufactured. Typical applications involve high strength levels and often failure critical components where toughness is important. These three alloys of the most common type are premium remelt aircraft quality steels conforming to AMS 2300 cleanliness. All are 0.03 max carbon, 0.010 sulfur, and 0.010 max phos, aka phosphorus. The three alloys are in order of increasing strength after the aging, and the UNS designation defines the chemistry. Maraging 200 UNS K92810 has 17 to 19% nickel, 8 to 9% cobalt, 3 to 3.5% molybdenum, 0.15 to 0.2% titanium, and 0.05 to 0.15% aluminum. Maraging 250 UNS K92890 has 17 to 19% nickel, 7 to 8.5% cobalt, 4.6 to 5.2% molybdenum, 0.3 to 0.5% titanium, and 0.5 and 0.05 to 0.15% aluminum. Maraging 300, El Mas Fuerte, is UNS K93120, has 18 to 19% nickel, 8.5 to 9.5% cobalt, 4.6 to 5.2% molybdenum, 0.5 to 0.8% titanium, and 0.05 to 0.15% aluminum. Maximum hardness in the annealed for all three is 321 BHN, which happens to be a 34 Rockwell C. Annealing is typically at 1500 to 1700 degrees Fahrenheit and would be performed by the producing steel mill. Aging is typically performed at 900 degrees Fahrenheit for 6 hours after manufacture of parts. Common specifications for Maraging steels are AMS 6512, AMS 6514, MIL S 46850, and MIL S 13881. Requirements within the specs and for parts are extremely important, especially in these high-strength steels. And it felt real weird last week because I did not tell you to check the specs. And so that wraps it up for today, folks. Thanks for tuning in, and this is Michael with Michael Talks Metal. If you've missed any of the previous videos or haven't subscribed, you could probably just go like this and click on them because they're right there. So, thanks for tuning in. I appreciate you watching. We'll catch you next week. Same time, same place. This is Michael with Michael Talks Metal. I'm out.